So last week we installed an AIO into our $800 gaming system. We found that we solved our temperature issue only to run into a power issue. So today we're gonna fix it by increasing the power limit, and we're gonna try to cool it down a little bit more by undervolting it. So hopefully we should get the best of both worlds. Stay tuned. When we built our $800 gaming PC, it performed impeccably. However, I was a little concerned about the temperature, and that kind of led us down this rabbit hole that brought us to where we are today. Unfortunately, because of that, it's no longer an $800 gaming PC. With the AIO that we installed, it's looking more like a $900 gaming PC now. So today, instead of throwing more money at it, we're going to try to improve its performance and its temperature by undervolting it. We're also going to play around with an overclock, but first, I got to pay some bills. So check out today's sponsor. Is your copy of Windows 10 unactivated? Well, it doesn't have to be, because with today's sponsor, VIP SCD Key, you can get a valid Windows 10 license for under $20. Stop dealing with that stupid watermark on the desktop, the valid license for Windows 10. Also, with an activated copy of Windows 10, you can upgrade to Windows 11 for free. Just go to the link in the description below and pick up a valid Windows 10 license key. During checkout, use the code CYBERCPU for a 25% discount. Once you have your key, go to your activation settings in Windows 10 and click on the link that says Change Product Key. Enter the product key you just purchased and hit Activate. Now you don't have to deal with that stupid watermark that come with running an unactivated copy of Windows 10. Now, on with the video. So there are people that will tell you that nothing in life is free. For the most part, that's a true statement. However, today I'm going to show you that some things actually can be free. Of course, that's as long as you don't count your own labor. So I guess in that case it wouldn't be free. So let's jump on the computer and see what we can do. So here we are on our system, and the first thing I'm going to do is we're going to go ahead and fire up Ryzen Master real quick. And while Ryzen Master is open, I think we're going to run a Cinebench run real quick so I can show you kind of the problem that we're trying to solve here. So it'll just take a second here to fire up Cinebench. A very short second though, because this system is really quick. So the first thing I want to do here is just run a multi-core test real quick. And then we'll open up Ryzen Master, and you'll see right here that our total socket power is 100%. And as of right here, you can see that our temperature is solved. We're under the limit. We're under the 85C limit. We're sitting at around 70C right now, but we're limited to 4.9 gigahertz because, well, because we're out of power right now. So if we were to run a single core test, then I'm sure we would be able to get the max speed of 5.1 gigahertz. However, at this point, we're stuck at 4.9. So let's go ahead and stop this run real quick here, and let's get into see if we can fix this right here. So the first thing we want to do is I'm going to go ahead and jump down into Curve Optimizer right here, and then we're going to turn on Precision Boost Overdrive. So what is Precision Boost Overdrive? In short, it's just a fancy term for the process that allows you to increase the power limits for your CPU. You see, by default, your CPU has certain limits to make it operate within its specific power draw range. By increasing these limits, you're essentially giving the processor more power. As long as you stay within your thermal limit, the CPU will boost to its maximum boost clock. Now, the three specific limits that Precision Boost Overdrive allows you to increase are PPT, TDC, and EDC. PPT stands for the package power tracking. This is the total amount of watts your processor is allowed to consume. TDC stands for the thermal design current. This is the amount of sustained current draw in amps that your processor is allowed to consume. Now, anyone who has studied electronics knows that watts equals volts multiplied by amps. So the amount of watts that the processor consumes is determined by the voltage of the processor multiplied by the TDC. As long as the resulting wattage is equal or lower than the PPT, then everything is cool, and your CPU should continue to boost until it hits its thermal limit. Now, the last one is EDC. This one stands for electrical design current. This is the limit that determines the amount of current that can spike for short periods of time. This is not the sustained current like the TDC. However, even with the EDC, the limit maxed out, your watts still can't exceed your PPT. Now, hopefully that was a good explanation. So let's complete this by throwing everything I just said out the window and maxing them all out and see what happens. Okay, yeah, just like I said, we're just gonna leave all these things at max. So right now, by default, they're already set to max. So essentially, by maxing these things out, you're giving the CPU all the power they could possibly take. Now, you don't have to worry about this damaging the processor because there's still limits in place, like your thermal limit, that won't allow the processor just to go out of control. And, you know, this isn't an Intel processor, so it's still gonna keep your voltage under control. But before we actually apply this, I wanna go ahead and enable the curve optimizer. And that's gonna be the next thing that we're gonna do right here. So the curve optimizer by default is turned off when you turn on Precision Boost Overdrive. So the way I'm gonna enable this is through all cores. However, you can do a per core, and you can we'll be able to adjust the values for every single core. But for us, we're gonna do all cores right now. And I'm also gonna change the auto offset to a manual offset. And this will allow me to change the curve optimizer offset for all the cores. This is essentially going to be our undervolt. Now we can do this per core and we can set a value for every single core individually, but that takes a really long time and I'm just going to go to all cores. Now what you could do is if you set this to auto, you can hit start optimizing and it'll go through the process of optimizing all of the different cores to find out what offset they can actually take. However, I have found that not only is this relatively inaccurate, but it also takes an incredible amount of time. So I like to go to manual and then just set an offset and see how the system runs. Now, as you probably know, I've already tested mine out and I can take the minimum of a -50 offset on this processor, which I was actually kind of surprised by. But we're gonna go ahead and leave it at that and we're gonna go ahead and apply this right now. So to do that, all we have to do is just save the profile and then hit apply. Now, when we hit apply, it's gonna wanna restart the system, just in case you have anything open in the background. So once we're done, we're gonna go ahead and hit restart now and hit OK. Now, the curve optimizer is one that I never had really played with before because it always took way too long for the computer to figure it out. Now, if you set the curve optimizer to automatic offset, then it will test every single core to see what offset it's capable of running at. If you do this on a per core basis, it can take hours. However, you don't have to do that. In fact, I found it to be a lot easier just to set it up with a manual offset. Not only does this take a lot less time, but typically the automatic offset will give you an invalid offset that will end up having to be troubleshooted manually anyway. Now, the way Curve Optimizer works is kind of like an undervolt. Let me explain. So as your processor boosts, it increases its V-core voltage based on what frequency the processor happens to be running at. So at this absolute peak boost, it might be running at 1.275 millivolts. But when your processor is running at 2 gigahertz, it could be running at 0.8 millivolts. Now, the way the curve optimizer works is it uses an offset value that can be either positive or negative to move the entire voltage curve. Now, these offset values aren't directly related to millivolts, like undervolting is. Rather, a -1 offset will move the voltage curve by 0.006 millivolts. This means that when you hit your maximum boost clock, your V-core voltage will actually be 0.006 millivolts lower than it would have been without the offset. Now, if you change the offset value to a positive one, then what you hit your maximum boost clock, your V-core voltage will be 0.006 millivolts higher than it would have been. And the entire voltage curve is moved in the same amount. Now, with all that said, there's really no practical reason why you would want to use a positive offset value. That's just going to increase your temperature and not allow your processor to boost as high as it would have. So if you're finding that you're having to go to positive offsets, then there's probably something wrong with your processor. Now, unlike undervolting, the way that the curve optimizer works is it allows you to adjust the voltage curve for each specific core individually. So let's say out of a 6-core processor, you have 2 really strong cores and 4 that are not so strong. You could set a lower curve on the 2 strong cores and a higher curve on the 4 weak ones. Also, Curve Optimizer allows you to change the curve per CCX as well. Now, we're dealing with a Ryzen 5 7600, so we only have the single CCX. But if you have a Ryzen that came with two CCXs, then you would be able to adjust the voltage curve for each CCX individually. So if you had one that would handle a lower voltage, then you could benefit from it. Now, let's jump back on the computer and test our new Curve Optimizer offset. Okay, so every time you run Ryzen Master or you change the settings in Ryzen Master, when you restart, it's automatically going to open up Ryzen Master again. Now, the reason why it does this is because it wants to know if the settings you changed were reliable. If they weren't, then it obviously wouldn't open the program up again. And then if you did end up rebooting, it wouldn't save those settings. It would go back to its default settings. So now that we got this fired up, I want to go ahead and run Cinebench again real quick, just to kind of compare it to what we did originally when we first started this. Because remember before, our power limit was spiked the whole time, and we weren't able to hit our maximum boost speed. So we're going to see if we can now. So to do that, all we're going to do is start a multi-core test, and we're going to jump back into Ryzen Master here, and we're going to let it go. And as you can see, we are definitely not within our power limit, and we're over our boost speed. We're sitting at 5130, and it's essentially not moving at all. It's staying there. And the reason why is because we're well within all of our other specs. Our temperature limit is way lower than it needs to be. In fact, if you notice, we were sitting in the low 70s before we touched anything, and now we're sitting in the low 60s. So that's a pretty good benefit right there. So we essentially lost like 10 degrees Celsius on our temperature, but we're also not power limited at all. We're sitting at 7% of our power limit. So the next thing that I want to do is set up an automatic overclock. Essentially, all this is going to do is change the maximum boost clock. Ryzen Master lets you set this to 200 megahertz over your CPU's factory maximum boost clock. So let's jump back on the system and let's get it set up. Okay, so we're going to go ahead and close Cinebench here because we're not going to need it anymore. And we're going to go ahead and jump over to the Curve Optimizer again. Now, from Curve Optimizer, the way that we set up our auto overclocking is essentially just by clicking on the tab Auto Overclocking. Now, all of our other settings for our Curve Optimizer and our Precision Boost Overdrive should remain the same. However, it's going to give us this one new box right here that allows us to change what our boost override is. Now, by default, it's going to be 100 megahertz. However, we want more. We're going to go all the way to 200. And then once you set that, you essentially just apply it and it restarts the system. And it should be similar like it did before. As soon as you hit OK, it'll go ahead and reboot the computer. So now that we have Precision Boost Overdrive configured, we need to see just how well this thing performs. Just like last week, I'm doing all this testing in Cinebench R23. Now, as you can see from this graph, enabling Precision Boost Overdrive alone increased our temperature. Now, that makes sense because we're essentially took away all of its power limits. So with the water cooling by itself, we averaged around 77C. But by enabling Precision Boost Overdrive, we averaged around 83C. Now, if we switch over and look at the frequencies that we were able to hit, we didn't get much for eliminating our power limits. I mean, we got a little bit more, but not enough to justify the increase in temperature at all. With the factory settings, we averaged 4,971 megahertz. And with Precision Boost Overdrive, we averaged 4,986 megahertz. That gave us a whopping 15 megahertz. That cost us a whopping 6 degrees increase in our average temperature. Now, the reason why this happened is because while we did get rid of the power limit that was holding us back, we ran right into the thermal limit again. So in this case, enabling Precision Boost Overdrive just wasn't worth it. However, all that changes once we enabled the Curve Optimizer. Because as you can see here, our temperature got a huge improvement from the Curve Optimizer. Now, granted, I'm running a -50 offset. So if you can't get that high of a negative offset, then your results are going to vary, of course. However, with the Curve Optimizer enabled, we got an average temperature of 64C. That's a 13-degree drop in our average temperature from the factory settings and a 19-degree drop from just having Precision Boost Overdrive enabled alone. So let's flip over to this graph and see what this gives us for our frequencies. As you can see, we finally hit our advertised boost speed on all cores, and it was extremely stable, as you saw in the example. In fact, the average boost clock was 5,140 megahertz. That's 40 megahertz over the advertised boost speed of 5.1 gigahertz. And it's stuck there through the entire run. Now, if we flip over to our power usage, this is also a pretty telling graph. So as you can see right off the bat that our stock configuration, we were definitely power limited. In the CPU stock configuration, we averaged around 90 watts, but we saw that when we started in Ryzen Master. Then, if you look at the red line for just Precision Boost Overdrive being enabled, it makes sense that our power usage would go up because we eliminated all power limits. This caused our CPU to average around 96 watts. But this unfortunately pushed us to our thermal limit, causing us to not be able to take advantage of more boost clocks. However, once we turned on the curve optimizer, as you can see from the graph, our average power usage for the total CPU power dropped to 66 watts. This explains why we were able to hit and maintain our maximum boost clock and do all of that at a considerably lower temperature. So now that we can see that the curve optimizer definitely works, what results did we get from our overclock? Well, let's go to the graph. As you can see here, the yellow line indicates our temperature from our overclock. We were pretty much all over the scale with it, peaking at over 80 degrees and dropping down as low as 73 degrees. This gave us an average temperature of about 74 degrees across the entire run. Now, when we switch to this graph for our frequencies, you can see that we were able to boost the 200 megahertz that we had set without any problem. In fact, we got an average boost clock of across all cores of 5,333 megahertz. Those are 7600X boost speeds, and it was stable across the entire run. So that 5.3 gigahertz was a sustained boost clock. Now, when we switch over to power usage with our overclock, you can see that the purple line, our power usage was definitely more than with the curve optimizer enabled. However, it was still lower than the stock configuration. We averaged about 83 watts of total CPU power across the entire run, while the factory configuration averaged about 89 watts. So for the most part, I'm actually really pleased with the results here. However, these settings were only tested in Cinebench. I also let Heaven run for a couple hours just to see how stable the -50 offset was in the curve optimizer, and I didn't have a single crash. So as of right now, I assume the system is solid. However, when it comes to the curve optimizer and using a relatively high offset, there's a chance that you could see instability at lower clock speeds. Remember, when we talked before about how the curve optimizer moves the entire voltage curve, well, the lower voltage may be adequate to run the processor at its top boost speed, but it may become unstable when it's running at lower speeds like 1 or 2 gigahertz. So the only way to really test the curve optimizer is by using the system. Ultimately, you shouldn't have instability with modern hardware. If your computer is crashing periodically or you're getting random blue screens every once in a while, then the problem very well could be your voltage curve if you set it down too far. So if that happens, you just need to raise the curve optimizer offset and your system should become stable. Personally, I'm going to leave mine at -50 if I can get away with it. Also, if you want, you can go to a per core offset with the curve optimizer and try to figure out which core specifically is having instability with the higher offsets. That's going to take a lot longer to figure out, but it's possible that you could have higher offsets with some of your better cores and lower offsets with some of your weaker cores. So it might be worth the time to invest to figure it out. But if you do that, write it down just in case you need to reinstall Ryzen Master someday. you know. However, the one setting that I do think I'm going to turn off is the auto overclock and just let mine boost to 5.1 gigahertz. Personally, I kind of like the lower temperatures, and the chances of my -50 offset being stable are more likely at 5.1 than they are at 5.3. But with that said, if you like getting something for nothing, then check out this video where I show you how to set up Windows 11 as a gaming system. There's lots of tweaks in that video to help you get even more performance out of your hardware for free. I also did the same video for Windows 10, and I'll leave a link to that in the description below. As always, you guys have a great day.